Okay, another video for electron configurations, this time electron configurations for ions, both cations and anions. So quickly I'm going to go over your notes a little bit on how we form these ions and what that means for the electron configurations. But just keep in mind that ions, all that's happened is that the atom has either gained or lost electrons, and so when we're writing electron configurations, we need to show that in the configuration. So either it will have more electrons in its configuration or less electrons in its configuration. And kind of how we add and remove those can be a little bit tricky. So we'll hopefully make it a little bit easier for you. So we'll start out by talking about negative ions here. Remember, negative ions means they have more electrons. So they've gained one or more electrons. The example here is chlorine. So for a neutral chlorine atom, it has 17 electrons, and it would have this configuration in noble gas notation. So make sure, if you're not up to speed with noble gas notation or electron configurations in general, watch those videos first and then come back to this one. So we have neon in brackets, 3s2, 3p5. If we form the chloride ion, which is Cl-, that -1 means it has gained an electron. So now we have 18 electrons. And so what we do for the electron configuration is we will add an electron to the highest energy level, right? So that's according to our electron filling rules. The electrons will always get added in the top right because all the bottom ones are all full already if we've used the rules correctly. So the only space available is at the highest energy level that was already being filled. So we had 3p5. We know that the p sublevel could hold 6. So if we're adding one electron, we'll just add it to that 3p, and now instead of 3p5, we have 3p6. So that one electron that was added, that was the electron that was gained to go from chlorine to the chloride ion. Okay, so negative ions, generally easier just to throw in those extra electrons. And we'll do an example in a second here from your homework assignment. The other type of ion, positive ions, cations, these ions have lost electrons. We have a couple of examples here. Calcium, neutral has 20 electrons. If we have the calcium ion, 2+ ion, it has lost 2 electrons. So if we look at its original electron configuration, argon in brackets 4s2, we need to remove 2 electrons, and we're going to do that by removing these 2 electrons that are in the highest energy level, right? When we do that, though, there's a little bit of a tricky thing. We cannot just have an answer of our argon in brackets, okay? That's not allowed. One of the reasons it's not allowed is just because this doesn't really show us anything about the electrons because it's all hidden inside of the noble gas notation. So what you have to do, even though it would be the configuration of argon, you have to go back to the previous noble gas, which would be neon, and then fill in the rest, 3s2, 3p6. Okay, so just keep that in mind. You can't have a configuration with just the noble gas in brackets. There has to have some piece of electron configuration in there. Okay, so that's one thing that can be a little tricky. Another thing that can be a little tricky here is if we look at this example with iron. Neutral will have 26 electrons. If we form the iron 2+ ion, where we lose 2 electrons, we need to do this very carefully. So if we look at the original configuration, argon in brackets 4s2, 3d6, we need to remove 2 electrons, and we remove the 2 electrons from the highest energy level. And this gets a little tricky because even though the 3d6 was written last, we have to look at this number here. So 4 is a higher energy level than 3. And so when we go to remove electrons, whether that's 1 electrons or 2 electrons or any number of electrons, we need to first go for the highest energy level. So it's actually these electrons that are going to be pulled. Okay, so we're going to remove those 2 electrons, and then that just leaves us with 3d6. So the final configuration for the iron 2+ ion is argon in brackets 3d6, with the 4s2 is missing. Those were the ones that were removed. So it can be a little bit tricky for positive ions. So we'll do an example from your noble gas notation homework assignment, one with a positive charge and one with a negative charge. Okay, so remember, this assignment is to be copied into your notebook. These are 2 questions we did in a previous video. We're going to do number 5 and number 6. So these are ones with ions. So starting with manganese with a +3 charge. And I'm going to give you a little bit of advice here. You do not have to do this, but I would especially warn you with positive charged ions, cations. It might be beneficial for you to write the configuration for a neutral atom before you write the configuration for the ion. Okay, so I'll show you why here in a second. We're going to do it with magnesium. So I'm going to take my own advice, and I'm going to write the configuration for a neutral manganese first before I answer this question. So manganese is right here, atomic number 25. Okay, so I'm going to use noble gas notation to write first just the neutral one. Okay, so I go back to the previous noble gas, which is argon. So I'm going to start with argon in brackets. So that gets me here. And then I have 4s2, and then 3d, 1, 2, 3, 4, 5. All right. So now that I have the neutral one, I can start to look at what it's going to, how this is going to change my original electron configuration. So if it has a +3 charge, does that mean that we are removing electrons or adding electrons to this configuration? Positive charge. Hopefully you said we are removing electrons. Remember, positive ions have electrons being lost. So if it's a +3 charge, it means that we're going to remove 3 electrons from this configuration. And this is where it can get tricky. Remember that the rule is that the electrons are removed from the highest energy level. So similar to this iron example, the highest energy level here is the 4s. Okay, 4 is a higher energy level than 3. So what we're going to do is remove these electrons first. So that's 2 electrons. We actually need to get rid of 3 electrons though. So where do you think we will remove the 1 remaining electron? Now we can dip into the 3d. So now we're going to remove just one of these. Okay, so here we're going to get rid of 2 electrons. Here we're going to get rid of 1 electron because we ran out of 4s. Okay, so once we do that then, oh, and we can fill in this. I mean, this is just to help you kind of, originally we had 25 electrons, but since we lost 3, we'll have 22 electrons. But I honestly think rather than doing this, it's more beneficial to write the neutral electron configuration so you can really see which electrons are being removed. So the noble gas notation then of manganese with a +3 charge is going to be argon in brackets. The 4s is now gone. We removed both of those electrons. 3d5, remember we got rid of one of those. So now it's 3d4. Quite tricky. Okay, so be careful with these ions. Next one, I think a little easier. Arsenic with a -3 charge. Okay, so arsenic is right here, atomic number 33. So if it were neutral, it would have 33 electrons. Okay, if we have a negative charge, does that mean we're adding or removing electrons? This time we are adding, okay? So we're adding 3. So if we started with 33, we're actually going to have 36 electrons. So again, if you want to, I'll just take my advice here. It's not as important with the negative ions, but if I wanted to write the configuration for a neutral arsenic, I'll just do that first. It won't take too long. So I'm going to use noble gas, go back to the previous noble gas, that's argon. Okay, and then from there, go from argon, 4s2, 3d10, and then 4p, 1, 2, 3. Okay, so it's 4s2, 3d10, 4p3. That was for a neutral one. But remember, now we have a positive or a -3 charge, so we added 3 electrons. So when we're looking at this configuration, where will we be adding those 3 electrons? We need to add them to the end, right? So the p sublevel can hold 6 electrons. So actually they can all fit here. So we'll just go to 4p6 at the end. So the new configuration for the ion is going to be argon in brackets, 4s2, 3d10, and now with the 3 additional electrons, it's going to turn into 4p6, right? So we're going to add 3 electrons here. Gives us 4p6, okay? So I think the negative, the anions are a little bit easier. There's more that could go wrong with the positive ions, but just be careful in general whenever you have some type of ion that you're doing an electron configuration for. Could be a little bit tricky, right? Good luck.